So welcome to the January 2023 Algebra 2 Regents. The way I'm going to choose to go through these questions with you is I'm going to go through questions that we've done in Unit 1 and Unit 2 first, and then I'm going to go through the ones that are not in Units 1 or 2 that might be a little bit easier. And then the last thing I'm going to do is go through the other ones, the ones that might take a little bit longer to. So I noticed that for the first and second one, they can be both done with the calculator. So the way I'm going to go through these is I'm going to do it with the calculator first and then go through it algebraically so that way you understand how to do it both ways. So for the first one, take my calculator. I always tell you that I use 2.1. Don't use 0, 1, or 2. You can use any other number you want. I just pick something random. And then above the on, I'm going to hit the store button, hit X, hit enter. And again, you should be pausing this and doing this with me. And then you're going to plug in the actual expression. So parentheses exactly as is, x plus 2. We're going to square that. Then there's a minus sign, 5 parentheses, x plus 2 again. And that should strike a chord like, that's the same number. And then when I hit enter, I get 2.31. So my magic number, the number that I'm targeting is I'm looking for 2.31, and then I match, right? So if I plug in the first one, x parentheses x minus 1, hit enter, boom, done. Okay. If you plug in any of the others, they will not work. And so do this yourself and make sure that you're good with that. So again, you're looking for something that is matching. Okay. Um, if you have two answers that equal that, then pick the one that is in simplest form, okay? Because then that's going to be valid. So now, how do you do this algebraically? So I noticed, and I said this to you earlier, right? X plus 2 is similar in both. So if I just take a different number like u and make that equal to x plus 2, just I want you to see what happens, then I have u2, like the band, minus 5u plus 6, and I'm going to factor this out. So I'm looking for two numbers that multiply to give me 6 and that add to give me negative 5. I know 1 and 6 and 2 and 3 multiply to give me 6, so which is going to add to give me a negative 5. So you should be able to come up with negative 3 and negative 2, right? That adds to give you negative 5 and multiplies to give you 6. So we have u minus 3 and u minus 2. And then now you can go back and plug in the original, right? So what was u equal to? It was equal to x plus 2. So I can do x plus 2 minus 3 in 1, and I can do x plus 2, right? So instead of u, we're plugging in x plus 2 minus 2. And so what are my two answers, right? I have x minus 1 and these cancel out, so and then an x. I usually put the x in front, and that's exactly what choice 1 is. All right, for the next one, you can also use the calculator for this one, right? So y1, plug this under y2, see where they meet. So we're definitely going to need to adjust the window for this. And so what do I mean by adjusting the window? If I were to plug these in and hit graph, I'm not going to see anything because my numbers are big, right? So what I have to do is I have to go to my window and I have to change it so I can actually see the number. So 5,000 is all the way at the top. So I'm going to go to my Y max and I'm going to change that to 5,000. Let's just do 5,100 just to be safe. And let's hit graph and see if we see anything. Okay, here we go. So that's the first graph, the left side, the Y1, and then there's my second graph. So now I can see that they intersect exactly at one point. So now I hit second trace. Option number 5 is an intersection. So I'm going to move over closer to that. That noise that you hear is my dog playing. So enter, enter, enter. And then it gives you 2.50, which is that answer right there. So question number 3 is something that you would have done in Algebra 1, but it's not difficult by any means. There is a formula that A is equal to P 1 plus or minus R to the T power is the formula that we have. So this right here represents the initial amount, like how much money you're putting in to something. So in this case, the car is worth 38,000 when it was first purchased. And then it's either 1 plus a number or 1 minus a number. So plus means that the amount is going up. Like for example, if you take money, put it into a savings account, that money will increase. But if you were to buy a car, like in this question right here, right? There's a car, and then after you take it off the lot, it decreases in price over years. So that's going to be 1 minus. So you use the plus sign when there's a growth, a minus sign when there's a decay. And then the R is the rate as a percent. So R equals rate. It's as a percent, or you could write it as a decimal. In this case, they are writing it as a decimal, and they always will. And then T represents time. Okay, so that's what each of the letters mean. So now, first thing I noticed is based off of what I just said, right? We have a 1 plus or minus. So since I know that this number right here is smaller than 1, I know it's going to be a decrease. So anything that says increase, I can automatically get rid of. And is it decreasing by 84% or is it decreasing by 16? So where are they getting that 16, right? So if you think about it, 1, right, minus the R is going to give you this number that's here, which is the 0.84, 0.84. So if we want to figure out what the R is, add R to both sides and subtract the 0.84. So let's just do this one at a time. So 1 is equal to 0.84 plus R minus 0.84. 0.84. So dollar minus 84 cents is 16 cents, and that is the rate. So the car decreases 16% each year because 0.16 as a decimal is 0.16, but as a percent is move the decimal places 2 places to the right or multiply by 100. So that is 16%. Okay. All right. So which one represents exponential decay? So we kind of just talked about this already, right? So exponential decay, the graph is going to look like this is exponential growth, right? Exponential decay looks like that. So just plug each of these into the calculator, and that's just a vocabulary one, which is why I was like, okay, I can teach this pretty quick. So if you plug each of these into the calculator, the one that looks like the decay function, this is the decay function, is going to be 1.8 to the negative x. Okay. All right. Question number 5, there was a question like this on the last Regents that we took. So if you take a look at all the remainders, they're all different. So you don't have to do any actual dividing. You could just do remainder theorem. So remainder theorem says you take the denominator, whatever you're dividing by, set it equal to 0. So x plus 2 equals 0, right? Minus 2 from both sides. So you get x is equal to negative 2. And then you take the negative 2, store it. So I'm going to take my calculator again, go back to my regular calculator. So I'm going to take negative 2, store that in for x, hit enter, and then I'm going to plug in the numerator, right? The x to the fourth. So x to the fourth minus 5x squared. And please make sure that you're typing this in correctly and that you're doing this yourself. Don't just wait for me to do this and hit enter. And that number gives you the remainder. In this case, the remainder is 2. They're saying that the remainder is 2. So which one has a remainder of 2? The first one. This one has a remainder of negative 14, 18, and negative 30. Okay, so these are out. All right, so the sum of the first terms of the series, this is something that we're going to come back to. All right, come back because we didn't go through this yet. This one, number 7, is something that's in units 1 through 2. So it says then f of 1/2. So all I'm going to do for this question right here is just plug in, if I take a look at this, right? Da, 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 da. Yeah, I'm just going to go ahead and store that in. So I have 1/2. We're going to store that in for x. Notice the store button comes in handy, I'm telling you, and then you're going to plug in the function. So when I plug it into the function, I get 0 as my answer. So what does this mean, right? So it says it equals 0, so automatically 3 and 4 are out. Okay, so it says and 2x plus 1. So how are we getting this 1/2, right? So if I do 2x plus 1 and I set that equal to 0, do I get 1/2? So let's see, minus 1 minus 1, I get 2x equals negative 1. Divide both sides by 2, I get x equals negative 1/2. That's not giving me the half, right? That's not the same thing as what I have here. So it's not going to be 2x plus 1, it's going to be 2x minus 1, and I can prove that for you, right? 2x minus 1 equals 0, add 1 to both sides, divide by 2, and you get x equals 1/2. So that does work. So the answer is 2. All right. So you could, so this is a calculator question, you could take each of these numbers, right? Plug this in for k and see if it gives you 27 minus 36i. So this is what I mean, right? So I go parentheses 6 minus, right? And instead of my k here, I'm going to put in negative 36, close that parentheses, hit I, which is second decimal point, close the parentheses and square it, and I hit enter. So I get this number right here, and if I do 27 minus 36i, and I hit enter, if I get exactly the same thing, then that is going to be my answer. So you can do it that way, and you'll notice that the only answer that makes sense that does work is option 3. That does work, or you can go ahead and actually do this yourself. So you could do 6 minus ki square means that you're multiplying it by itself, right? And then FOIL that out, so you get 36 negative 6ki negative 6ki plus k squared I squared. And then when you add this together, you're going to get 36 minus 12ki plus k squared, and then I squared is equal to negative 1, so that's going to be minus k squared, and then we want to see if that equals 27 minus 36i. And then you can plug in the numbers here. In my opinion, doing the first way is definitely a lot easier. And you're done. Question number 9, we did do this, right? You have to get a common denominator. You could also do like plug this under y1, plug this under y2, see where they meet. So let me just show you how to do that, right? So go to your calculator. To get the fraction bar, you hit alpha y equal, type in x plus 2 on the top. On the bottom, you have an x, and then you go over to the right, hit plus, another fraction, so alpha y equals option number 1, x on top, 3 on the bottom, right? And then over here, plug in the second y. So after you plug in, right, you go to the table, and so we're looking across from these numbers, negative 3, 0, 3. So let's check. Across from 0 is error, error, but that is not the same because not all errors are equal. Negative 3 doesn't have y1 and y2 the same number, so that's not right. So it looks like the only answer is going to be 3, and that works. Okay, so 3 is the solution. If you didn't see it that way, you could hit graph. I still have my window from before, right? That's the first one, that's the second one, but again, because I can't really see it because I changed, I think, the y to like 5,000 something. So if I hit zoom, option number 6 is zoom standard, or you can reset the calculator. You should be able to see it a little bit better. Question number 2 is also very similar, right? Plug the first one in under y1, the second one in under y2. So you can see here the graph crosses at 3, okay? So like I was saying about number 10, I'm sorry, I was getting a little ahead of myself. But question number 10, how many real solutions exist? Real solutions are when they cross, right? So plug in your y1, plug in your y2, see how many times they meet. We don't care where, like at what point they meet. That is not what it's asking us. Some of you get bogged down by this. So you go to your calculator and you plug it in with the magic of pause, and then hit graph. And again, you're looking to see how many times they meet. So that's the first one. Where's the second one? Second one. Okay, so they don't meet, right? And if you wanted to be safe and just check out, if you're right, because, hey, what's happening to the right? So you could zoom and hit zoom out, which is option number 3. And then let's just zoom out at that point, and you should be able to see it a little bit better, right? So that's the first one, right? They don't ever touch. So answer is 0. Identity, right, is the left side equal to the right side. So you can't plug that under y1, but you could store a number in for x, store a number in for y, see if the left side equals the right side. And the only one that actually does work out is option number 2. right? So how do you store a number? I showed you store for x. You can store any numbers you want, a, b, c, d, y. So I used 2.1, I told you, for x. So store that in for x, hit enter. I'm going to choose 5.9. I don't know. I'm just, again, picking a different number. So how do you store it in for y? So you hit alpha, and y is on top of the 1 in green, and then you hit enter. And then again, all you do is plug in the left. So x to the third, hit right, and then plus y to the third. So alpha 1. Oh, I forgot the plus sign. Insert the plus sign to the third, hit enter, and then see if that equals the right side, which is x plus, I think you get the point, y, close parentheses, to the third, hit enter. That is not the same, so that's out. So the only one that makes sense is the second one. If you wanted to do this algebraically, you would have to do distributive, right? Distribute this, combine like terms, and you'll see that x to the third plus y to the third is equal to the second one as well. All right, question number 12. We did do this. So, and you did this in algebra 1, but when you're dividing, you subtract the exponents. You can store a number in here, right? Store a number in for x, store a number in for y. No, just store a number in for x, plug this in, and then see which one it equals. So this is very similar to the first question that we did. But I do want you to show you how to do this algebraically. So 1/5 minus 1/2, and we want to see what that can be written as. So 1/5 minus 1/2, when you plug that into the calculator, you get x to the negative 3/10. And again, please do this yourself. Negative means it gets kicked to the denominator, it gets kicked down. So this is going to be x to the 3/10. And if there's no number on top, there's an imaginary 1. So automatically this is out, and this is out. So the only one that makes sense is this one right here. But let's make sure that we understand that. So 1 over, right? 10 is our denominator. So bottom left. So that's our root. And x to the third, the 3 is on the top. So that is our exponent. Okay. So that's option number 12. We did not do number 13 yet, so I'm going to skip this for right now. Right? Yeah, I'll skip it for now. Number 14, which one is accurate? This is not a math question, but you need to remember this. The more random something is, the better, right? The less bias it is. So more random. My dog is just checking to see if you're paying attention. The less bias there is. So that is question number 14. Inverse. Can I do this real quick? I know we didn't do this yet, but this is not hard. So f of x is the same thing as y. So y is equal to 1/2 x plus 2. How do you do inverse? Step 1, take x and y and switch it. Step 2, get the y by itself. So let's just do this real quick, because this was in the last Regents that we did, and I wanted to teach it to you so bad, but I didn't. But let's just do this, right? So we're going to take any x's and switch it with y's. So we get x equals 1/2 y plus 2. And then we're going to get the y by itself. Yeah. So how do you do that? Move the 2 over, so minus 2. So this cancels out. So x minus 2 is equal to 1/2 y. To get rid of the 1/2, multiply both sides by 2. Right? So this cancels out. So I get y is equal to, distributive here, 2x minus 4. And that is choice number 3. Okay, simple. Come on, we could do that. If that confused you, like I said, we didn't do that yet, but nothing crazy. So given da da da, for what values of x will f of x be greater than 0, which means that the y is going to be positive. So this is also a calculator question. So I just went ahead and graphed it. Well, I plugged it in exactly as is, and now I'm going to hit graph, and let's see what happens. So, okay, so I see a wacky looking graph. Okay, so it says, where is f of x or y going to be greater than 0? So I'm going to go ahead and just like see, hold on one second. Okay, perfect. So I was able to take this and put it into the actual thing. So what we want to see is, where is y, right? Where is y positive? So y is positive everywhere here, right? So this number right here looks like it's going to be -1, -2. So at -2 and to the left is positive, and over here, this number right here is 3. And from there, 3 is, yeah, from 3 up, right? Or to the right. So how do I say that? X is less than -2 or X is greater than 3 is where my Y's are going to be positive. Because here my Y's are negative. See that? Right? These are negative Y's. All of these are negative. Over here, up here is where Y's are positive. Let me just go ahead and get rid of all the mess so you can maybe see that better. And again, just check this on your calculator as well. But you should see pretty simply that 2 is going to be our answer for that. So which approximate values of x will log da da da, right? So this is straight calculator. So I'm going to go to my calculator here. Instead of my y equals, let's clear that and let's type this in. So with log, there's no number here on the bottom. So I can just literally hit the log button, which is above on, above store is ln, and above that is log. So I'm going to put x plus 5, close my parentheses, and over here under y2, right? So here's y1, here's y2. How do you get these absolute value into the calculator? You hit math, go over to num, and then ABS is option number 1. And there you go. So now you put x minus 1, go to the right, and it's minus 3. So for which approximate values will they equal each other? So to do that, we hit graph. So that's the first one. These are a lot of questions that we could do on the calculator, right? So there are 2 answers here. Ba, 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 ba. And I can see right now that, look, if you take a look, the 5, right? At 5 is where they definitely intersect as well, and then a negative number. So I know that if I look at my answer choices here, right? This one has a negative number and not 5. This one has 5 and 1. So it's not this one. It's not just 5. So let me just check. So positive 1, no, it doesn't cross at positive 1. So my answer is going to be choice 3. You could do second. Let me just go ahead and show you. Second trace. Option number 5 is intersection. So I already know the one on the right is 5. If I go to the number on the left, hit enter, 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 and I should get that negative 2.41, and I do. Okay. All right. So this is another question that you could do on the calculator. Store a number in for A, store a number in for B, and see which one gives you a cubic polynomial. A cubic polynomial is basically just x to the 3rd power, right? So if I take a look at this, there's nothing that I can cross off the board because they all have to the 3rd power, right? When I multiply that, that gives me to the 3rd power. When I multiply this, that gives me x to the 3rd power. This actually gives me x to the 4th power, so I can get rid of 3. And when I multiply that, that gives me x to the 3rd power. So choices right now are either 1, 2, or 4. So if I absolutely have to guess. So now this just becomes me plugging things into a calculator. So if I go, let me just reset my calculator. Second plus 7, 1, 2 helps me reset my calculator so I don't have to sit there and adjust everything and go to my y equals. So you see how it says x minus a? I don't have an a, so I'm just going to pick a number. So x minus short 2.1, my favorite number, right? Close that, and then I open up parentheses again, and now it says do x squared, and then I have plus b, right? So my other favorite number is 5.9, so you just pick any 2, and then we're going to go ahead and hit graph, and we're going to see if it has exactly 1 root, which means it crosses the x-axis exactly once. And we also want to see as x approaches infinity, which means as we go to the right, my y is going to go down. That's what that means. So let's see if that happens. So right now it looks like as I go to the right, my y is going up, but I don't see the whole graph, right? So let me do some zooming out. So option number 2, hit enter. I think I zoomed in. Hmm? Let me hit zoom. Yeah, I definitely zoomed in. So let's try that again. Zoom 3, let's zoom out. And it's going to give me back to this. If I zoom out some more, I'm going to get my, yeah, my wonky looking thing. So as I go to the right, look at my y, it's going up. So that's not it, right? So if I plug in the second one, so a minus x, right? So if I go over here and instead of my x minus 2.1, if I do 2.1 parentheses 2.1 minus x, right? And then if I plug in the x squared, it says x squared plus b, so everything else stays. Now let's see if that works. As I go to the right, yeah, there you go. As I go to the right, my graph is going down. So that's option number 2, right? So as I go, it looks something like this. So as I go to the right, my y is going down, whereas in the other one, my y was going up, okay? Question number 19, we're going to skip this for now, come back to it. But we did a lot so far. Question number 20, we're going to skip this for right now. Question number 21, like I said, this one is low-key algebra 1. It says which recursive formula. So recursive means that you have something that looks like this, like a an minus 1 or an an plus 1. So these two are not recursive. So those are wrong automatically. I said I'm just going to go ahead and do this because I already started. Then it says each tree, a farm initially has 150 trees. So that's my initial. They both say that. So I can't cross anything out yet. And then it says each year, 20% of the trees are cut down and 80 seedlings are planted. So there are 80 seedlings. These represent the 80 seedlings that are planted. And then 20% of the trees are cut down. So remember our formula of 1 minus r. Remember this? So 1 minus r is equal to 20%, which is 0.20. So what number is going to make that true, right? To get to a dollar from 20 cents, you have 80. So r is equal to 80. And so that means our answer choice is 2. This is banking on the fact that people will not remember the formula, the 1 minus r thing. Um, yeah. All right. So this is similar to the question that we did in the beginning. Question 22, we have a focus and a directrix. So I don't have graph paper, but I'm just going to go ahead and sketch this real quick. So I have focus of 4, 3, 4, negative 3, and I put a dot here. And then my directrix is y equals 1. So this is at 1. So I look halfway between, so between 4 and that 1 right, sorry, between negative 3 and 1, my focus is going to be at 4, negative 1. So this is 4 comma negative 1. So this first number is my h, the second number is my k. My p is the distance between this, which p is equal to 2. So now I have to see is my parabola positive or negative. Let me just clear some space real quick. So here's my vertex, right? If my parabola was going up, then it would cross that directrix. That can't happen. We can't ever cross that line. That directrix is like a shield. Okay, you with me? So it's going to go in the directrix of in the direction of the focus, which means that it's going to be facing down. So my p is going to be negative. So what did I just find? My h and my k are both 4 comma negative 1, and my p is equal to negative 2. So now I plug it into my formula, right? So my formula is y equals 1 over 4p h minus k squared x minus h, sorry, x minus h squared plus k. And so now I'm just going to plug in some numbers. So 1 over 4 times p is negative 2. That's negative 8. So I have to have a negative 8 in it. So automatically 1 and 3 are out. And it's x minus h. My h is 4, right? So x minus 4 squared plus k. My k is negative 1, so I have a minus 1. And this is equal to y. So yeah, automatically I can see this is x minus 4. So the only one that's left that has x minus 4 in it is choice 4. And if you were to multiply both sides by negative 8, right? You can manipulate this a little bit, right? Add the 1 here, so you get y plus 1. Multiply both sides by negative 8 to get it to look like number 4. All right, question number 23 is straight calculator. We're doing good. All right, so we are doing good. So all I did is I took the original, which is this right here, and I plugged it in, and I also plugged in the first one, and I'm looking to see which one is approximately equivalent. So if I look over here and I go to my table, because that'll help me see the values. Okay, those are pretty close, right? So the first one is exactly the same, which makes sense. 36, 138, 36, 151. So these numbers are pretty close to each other. So you want to see which one is the closest. So plug in each of them, right? So now you go under y equals, and then plug in the second one. So you'll see that the one that is the closest is option number 1, and that's how you do question number 23. All right, this one. Which one shows a quadratic function with two imaginary zeros? So now stay with me, okay? So this has, the first one has, this is a real zero. That has no imaginary zeros because it's a quadratic. It's a quadratic. And this right here tells me how many roots there are. So this is actually a double root, right, at whatever this number is, okay? So this is not, this has real roots, okay? This question or answer choice right here, number 2, has imaginary roots because it doesn't cross the x-axis at all, right? Doesn't cross the x-axis at all. If I take a look at this, this is wrong automatically because this is not even a function, right? So function means that if I draw a vertical line, it crosses exactly once. So number 4 is not even a function. So that's out. And this one right here is this, it looks like this, right? Remember what we did with our table? So it is a graph that is a quartic. This is a quartic, which means that it's going to be x to the fourth. So if I take my calculator and I plug this in, I'm going to get something that looks like that. Not exactly. And this has 4 roots, right? 4 roots, which means that we have 4 imaginary zeros. We only want one with 2 imaginary zeros. So that is option number 2, right? This one has 2 zeros because it's a quadratic. X squared leading coefficient is negative. This kind of is like our bridge uh, problem. All right, so that is question number 24. All right, we're doing good. Determine the zeros. It says algebraically, so you can put this into the calculator and see where it crosses the x-axis, but since it says algebraic, let's do it algebraically. So split this, factor out the left, so I have 3x squared parentheses x plus 4, and then we're going to factor out the right, negative 3 parentheses x plus 4, okay? And then the x plus 4, we're going to take it and write it once. We're going to write down the rest, 3x to the second power minus 3, and then we're going to factor it as much as possible. So x plus 4, yes, x plus 4 is factored as much as we can, but this right here is not. So I can take out a 3 here, and I'm left with x squared minus 1. Bup, bup, good. And then this is x plus 4. So I'm looking for zeros here. I can go further. This x squared minus 1 can factor into x plus 1, x minus 1. But even if you didn't know that, you can still get your answer. There is an x plus 4 there, and there's just a random 3. Okay, so now I'm looking for the zeros. So if I do these, I set each of these equal to 0. So for the first, second, third, and fourth, right? The first one makes no sense. 0 equals 3. That does not make sense, right? This one right here, x plus 4 equals 0. To make this true, I get minus 4, so I get x equals negative 4. So that's one of my zeros. This one right here, I have x plus 1 equals 0, so x equals negative 1 is another one of my zeros. Here I have x minus 1 equals 0. Add 1 to both sides, I get x equals 1. So those are my 3 zeros. Okay, and how do I know? Because our highest exponent is a 3, which means I have 3 zeros, right? 1, 2, and 3. All right, I'm done. Given the function, they love these questions. All right, so watch these. So I have something to the x plus 1 is equal to something. So I'm going to rewrite this with a base of a and with a fractional exponent, right? 2 is my exponent, goes on the top. Exponents go on the top. 3 is my root, goes on the bottom. So a to the 2/3. As soon as you have the bases the same, which they are here, they can cancel out. So I have x plus 1 is equal to 2/3. So then how do I solve, right? Minus 1 from both sides. And this becomes a calculator question. X equals 2/3 minus 1 is negative 1/3. And I'm done. There's my x. This one is something that we're gonna come back to that. Can I just show this to you real quick? So for this one, it's asking you if it's independent. So this is a formula. P of A and B just is the same thing as doing P of A times the P of B. So what is the P of A? 1/3. So we're just doing 1/3 times P of B is 5/12, close parentheses, and just multiply them. 5/36 is your answer. Okay. I know I wasn't supposed to do that. It's all good. I did this last time, and so I'm going to do this again. Dun, dun, dun. So this is a straight calculator question. We're going to turn it on. And like I said, I know we didn't go through this in class. It doesn't matter. But we did do this when we did a Regents. They love to ask questions like this. So this is normal CDF. So second vars next to the clear. Normal CDF is option number 2. So hit that. And now it says lower and upper. So my lower is 690. The upper is 900. So I'm going to put that in 690. My upper is 900. And again, I know I didn't go through this with you. No biggie. Then it says the mean is 680. So I'm going to put 680 in, and my standard deviation. Oh, again, she's just making sure you're paying attention. Is 120. So we're going to put the 120 in and then hit enter. Sorry that she just periodically does this. So I have 0.433 da da da, and it's asking you to the nearest percent. So 0.433 to the nearest percent is about 43%. Move the decimal 2 places to the right. Right? 1, 2. So this is, we want to show work here. So normal CDF parentheses, and we plugged in our 690, comma 900, comma the mean goes next, which is 680, and the standard deviation is 120, and we hit enter. Okay, so 43% is our final answer. Okay, this one, you have to get this right. Go to the calculator, clear, hit stat. Under delete is stat, edit is option number 1, plug the numbers in. Okay. All right, so after you put the numbers in, hit stat, go over to calc, and then it's telling us we need an exponential regression. So we're looking for exp. So I just go up, and exp reg is option number 0. So you hit 0, hit enter, enter, just keep hitting enter, and you're going to take these numbers. The hardest part here is going to be rounding it correctly. They say they want us to round it to the nearest thousandths place. So let's do that. The first number is tenths, hundreds, thousandths, so you look at the number to the right. So since this number is a 5, that 8 goes up to a 9. So it's going to be y equals, must make sure that you put the y equals there. So it's going to be 2.459, right? Again, we're rounding to the nearest thousandths place. So you look at one number to the right, which is the 5. So 5 or above, we're going to give that 8 a shove. Remember that? And then it says put the b next, so whatever our b is. So we're going to do the same thing, tenths, hundreds, thousandths. Look at the number to the right, 5 or above. We're going to give this 5 a shove up, right? So that's going to be 1.616, 1.616, and it's raised to the x power. So there is our work. All right. Then it says write this expression. This is completely doable. They just want us to take the first two, multiply them, and minus 3 times c. Okay, so x to the third power plus 2x minus 1. That's our a. We're going to multiply that by x squared plus 7. And we're going to do minus 3 times, right? We're just following this. Minus 3 times whatever c is. So c is x to the fourth minus 5x. This is a straight algebra 1 question. There is no algebra 2 here. So here, when you're multiplying, you do, let me go back to black, distributive property here. So this is going to be x to the fifth power. This is going to be plus 7x to the third. This is going to be 2x to the third. I like lining up as I do. That's up to you. And this is going to be plus 14x. Okay. So now I did the first one, the second one, and I'm going to do the same thing with the last one. So negative 1 times x squared is negative x squared. Negative x squared. Yep. And then negative 1 times 7 is negative 7. Okay. So now I'm just going to rewrite the rest of it. So minus 3 parentheses x to the fourth minus 5x. That way I don't get stuck. So I'm going to combine some like terms. If you wanted to distribute this, you could have. Some of you might feel more comfortable doing that. I just try not to skip steps, but negative 3 times x to the fourth is negative 3x to the fourth, and negative 3 times negative 5x is positive 15x. Okay. So now that I have all of this jazz, I'm just going to combine some like terms here. So the x to the fifth is by itself, so I'm just going to bring this down. X to the fourth goes next, so I have right here, right, this negative 3x to the fourth. So I dealt with that, I dealt with that. You see what I'm doing? Trying to be clean about this. Then my x third terms are right here. So this is going to give me plus 9x to the third. And then I have my x squared term, which is right, so I dealt with that. I have this right here, the negative x squared, so I put negative x squared next, da-da-da. And then I put my x terms, so 14x plus 15x is going to be positive 29x, and then the number that's by itself, right, is negative 7, so minus 7. So now it says put it in standard form. That's why I decrease the numbers 5, 4, 3, 2, 1, and nothing. Okay, so this is my answer right here. Okay, completely factor. Okay, so we could do this. We did factoring before. So over here, x to the fourth, I have x squared, and then I have a number by itself. Life would be great if this looked like this, x squared minus 5x plus 4. So what I could do is I can let something else, right? I can say let u equal x squared, right? So let me just change these x's into u's. U. I'm going to factor this. I did the problem like this earlier. The first one, actually, when I was showing it to you algebraically. So this one, I'm looking for two numbers that multiply to give me 4 and add to give me negative 5. Okay, so what are they? 4 and 1 has to be, right? So 4 times 1 is 4, but if it has to add to give me a negative, they both have to be negative. So now I have u minus 4 and u minus 1. All right, so now I've done that part, and now I can go back and plug in my x squared in for my u's. So I have x squared minus 4 and x squared minus 1. So both of these are factorable into double bubble, double bubble. So x squared minus 4 is going to be x and x. To get negative 4, positive 2, negative 2, right? To get x squared minus 1, x and x, positive 1, negative 1. The popo's coming. And so there's my answer. Okay, so we did that. We notice we didn't skip a lot. 32 we're going to skip for now. Solve this. This is straight. We did this lesson 2. Lesson 2. So minus 5. Get the weird thing by itself. This is my weird thing. So minus 5 here. So I have square root of 49 minus 10x. I taught you guys well. Folks, you folks, not just guys and girls. So now to solve this, to get rid of the radical, we are going to square whatever you do to the left, you do to the right. So I have 49 minus 10x, because these two cancel each other out, is equal to 2x minus 5. And then when I square it, I multiply it by itself. Okay. We got this. So we're going to do FOIL here. So that's going to be 4x squared minus 10x minus 10x plus 25 is equal to 49 minus 10x. Move everything over to one side. So minus 49 cancels, add 10x, This cancels out. So now we have 0 is equal to 4x squared. The negative 10x, positive 10x can cancel each other out, but I have negative 10x. And then I have minus 24. So I notice right away that 4 goes into all of them. So I can divide everything by 4, divide this side by 4. So I have 0 is equal to 4x squared divided by 4 is x squared. And then I have, wait, what? We cannot divide it by 4. We can divide it by 2. Come on, chicken nugget. We can divide this by 2, right? Because 10 doesn't go into 4. So divide everything by 2. So I have, this is now going to give me 2x squared minus 5x minus 12. Okay. So now we're going to do AC method. This is one of the methods of factoring. AC method says I take my A, take my C, multiply it. So two numbers that multiply to give me negative 24 and add to give me negative 5. So what are two numbers that multiply to give me negative 24 and add to give me 5? 12 and 2? No. 6 and 4? No, 8 and 3. Okay, so 8 and 3. So it has to multiply to give me a negative. So one of the signs has to be negative, the bigger sign, right? So this has to be negative 5 because negative 8 plus 3 is negative 5. That works. And negative 8 times 3 is negative 24. So I take, right, these two terms, bring it down. So 2x squared comes down, the negative 12 comes down, and the negative 5 gets broken up into negative 8x and into positive 3x. So now when I have four terms, cut it down the middle, so factor the left, factor the right. So I have 2x, and then I have x minus 4 here, and then I have 3 and x minus 4 here. So now I take my x minus 4 and I write it down once, and I write down what's left in the others. So x minus 4 comes out, so that's dealt with and that's dealt with. And then what's left is a 2x and a positive 3, so I have 2x plus 3. And I'm going to, since it says solve, I'm going to set them equal to 0, split them, x minus 4 equals 0, so x equals 4 is one of my answers. And then I have 2x plus 3 equals 0, minus 3 minus 3. So I get 2x is equal to negative 3, divide by 2, divide by 2. So I get x equals negative 3 halves. Okay, so this is what I think. However, I have to actually plug this in. So I kind of cheat with the check. Here's my check. So I'm going to y1, go to y1, type in my original, which is negative 49 minus 10x. When I go fast, I start getting sloppy. Square root of 49 minus 10x, and then I go to y2, and I put in my 2x minus 5. So I'm going to go back into the original. I could, since I didn't have that, let me just do this right. This is plus 5, and then this is 2x, okay? So now I go to my calculator, and I'm going to turn it on, and hopefully, okay, through the magic of YouTube, I was able to go ahead and plug this in. Notice that after the 10x, you're going to get rid of that radical. So just hit the right arrow and then put the plus 5. Please type this again. Don't just watch me do this. Please actually do this yourself. And so now I'm checking my two numbers, right? So my two numbers that I'm checking are 4 and negative 3 halves. So I'm going to go second graph, check out 4 across from 4. So 4 works. So this one is definitely an answer, okay? Now I'm going to check negative 3 halves, but I can't get negative 3 halves here. So I hit second window, which is table set, and I'm going to put in negative 3 halves. 3 divided by 2, and then I'm going to go to my table. And those two numbers are not the same. Y1 and Y2 are not the same. So that means that the negative 3 halves doesn't work. So my only answer is x equals 4. Okay, so x equals 4. I'm going to make that pretty big. Okay. I'm going to skip this for now. This one, straight calculator question. You go to your graph, you type it in, and then very simple. So for this one, so please plug it in exactly as is, nothing crazy. And then I'm going to hit graph so I can see what's going on here. So, all right, I have a a line. It looks like it's going a little bit down here. So I'm just gonna see if I can bring this over so you can help me graph it. Okay. So I noticed, let me just move this a little bit. All right, so I don't have anything there. Here, perfect. So I'm noticing that over here, if I go to my table, right? If I go back to this and I go to my table, so second graph, I can actually see my points here. So 0, 1.8889, right? So it's a little bit under 2. So 0, 1.8889, somewhere around there. I'm going to put a dot. Do I have any whole numbers here? So 2, 1, 2, 1. I'm going to put a dot. You see what I'm doing, right? So I'm being very specific. 3, -1. So 1, 2, 3, -1. I'm putting a dot. What's another one that I could do? 4, -7. So 4, 1, 2, 3, 4, 5, 6, 7. Right? So those are 4 solid points that I can do. And then I don't have anything else. Let's just check. If I go to the negative, right? Okay. A couple of things that I could do here, right? So this, and then if I keep looking, and this number right here, look, if I keep going up, right, it gets very, very close to 2, right? So what's happening here? So at -10, I'm going a little bit under 2. Don't hit 2. So I'm going to go like this. I'm going to go like this. I'm going to go like this. I missed this point right here. And then I'm going to go down to that point. Oh, check that. So you want to try to get as exact as possible. Don't just go doo, right? Try to get exact as possible. Put arrows on the bottom and arrows here. So you can't, it doesn't cross into 2, right? It's going to be a little bit under. This is called an asymptote at y equals 2, right? So it's not going to cross into, it's not going to go to 3. It's just going to keep going. So then it says describe the end behavior. So as c of x approaches positive infinity, right? What's happening? So as we get to the right, my graph is going down towards negative infinity. So I'm going to write that down, negative infinity. And then what's happening as x approaches negative infinity, right? As we go to the left, right, our graph is getting very, very close to 2. So we're going to write c of x is approaching 2. Doesn't ever get to exactly 2. All right. Average rate of change, lesson number 1, right? First formula that should come to mind, y2 minus y1 over x2 minus x1. So now this just becomes plug and chug, okay? So, so January is 1, June is going to be 6. So this is going to be month 6. So m equals 6. And October is month 10. So m equals 10. So I'm just going to plug some numbers in. So go to the calculator. So notice I am just plugging things into the calculator. Sign is right above the comma under the apps button. I have 55.25. I'm going to keep my mode in radian. And so now I'm just going to go ahead and go to my, I don't even care about the graph. I'm going to go to my table. So second graph, and I'm looking for 6 and 10. Okay. So let me just go check my window set. Let me just start it at 6. So I have 6, and then I have this lovely number right here, 75.504. So 75.504. And then across from 10, the number that I have is 59.992. 59.992. And so now I'm plugging it into my calculator, right? So I have, this is my y2, y1, right, sorry, my y1 and my y2. All right, so now I'm plugging it into my calculator. This is, instead of calling these m's, I can call this x1 and x2. So now I have my y2, so 59.992 minus 75.504 divided by x2, which is 10, minus my x1, which is 6, and then this becomes a calculator question. And so I literally just plug it into the calculator and I get a number, and it's asking me if I take a look to the nearest hundredth. So this is going to be negative 3.88 if I round this to the nearest hundredths place. And so now the last thing it says, explain what this value represents. So since this is temperature, okay, so it's decreasing temperature. So Buffalo's monthly temp is decreasing about 3.88 degrees Fahrenheit per month, right? From, and then we have to write the months, right? From June to October. So notice I'm using the scenario that they're giving me. I'm not just saying, oh, it's negative 3.88. It's going down 3.88. I'm saying, what is the context, right? Given the context. Good. So for this last question, I am going to go over this with you, even though I haven't specifically taught it. It's just plugging things in. So if you take a look, this guy, Mark, makes t-shirts. So this is your formula, right? It tells you what each of these are. So the first thing we're going to do is we're going to write an equation. So T is equal to T0. So do we know what our T0 is? Our T0 is our initial temperature. So if you take a look, it's 400. So I'm going to put parentheses here, put 400 here, minus my TR. TR represents the room temperature. So if I keep looking, it says the room temperature is 75 degrees, right? So I'm going to put a 75 here. Nothing crazy. Then there's an E. Then there's a negative sign, right? So now it says I'm going to put the R. So the R is the rate of cooling, which it's telling you the rate of cooling is this right here. So I'm going to put 0.0735. And then it says, so I don't know what my T is. So I'm just going to leave that there because that's my variable. And then I have plus the room temperature again, which is 75. This right here, what I just did, da da da, 2 points. Okay. Then I'm going to use that equation, and it says after 5 minutes. So it's using the equation to find the temperature of the shirt to the nearest degree after 5 minutes. So 400 minus 75 is 325. E to the negative 0.0735 T. So now my T, they're telling me to the nearest, to after 5 minutes, so I'm putting in 5 here, plus 75. And then I plug this into the calculator, hit enter, and this gives me about 300. It says to the nearest degree. So plug that into the calculator, you're going to see that it gives me about 300. Okay, that's 4 points. Okay, maybe 3 points. 3 points right there. Okay. Then it says after 8 minutes, the hoodie measured 270. So we're going to put 270 as my answer. So 270 is equal to, and I'm going to write down the rest of it, right? It says the hoodie is now 450 degrees. So it's not 400 anymore. It's 450. So 450 minus the room temperature is still 75. E to the negative 0.073. Well, this says the rate. No, no, no. So the rate has changed. Determine the rate. So we don't know the rate, right? So we're going to put this as we're not sure what the rate is. Um, but we do know it's after 8 minutes. So it's negative 8R. The R represents the rate of cooling, which is what we're going to find. The 8 minute represents the time, so that's 8, and it's still negative. And then we have to put plus the room temperature, which is plus 75. Now, this does not tell us to do this algebraically. So you can put this straight into the calculator. I'm just going to go through this with you, right? So you go to y equals, everything that's there, let's just clear it. So we're going to put 270 in for the y1, right? Because that is the hoodie measurement. And then for the second one, we're going to put in the second equation, which is 450 minus 75, da da da. I did come back so I can show you where the E is. Above on, above store is ln. Above the ln is E, so second and ln. And then I put in -8 instead of R. I'm going to put in X. And then I go to the right and hit plus 75. And I'm looking to see where they meet. And I'm going to hit graph so I can see what they look like. So I'm obviously not going to be able to see the 270 because it's all the way at the top. So I'm going to hit my window whenever it feels like doing whatever. Okay, so I'm going to hit window and I'm going to go to my Y. And since I have 270, a good Y might be 300, any number bigger than 270. And I'm going to hit graph. Okay, there's my 270. And do I see my actual function? The second one. There we go. Okay, so now I'm looking to see where they intersect. Where is one equal to the other? So I hit second trace. Option number 5 is intersection, and it already puts it right where I need it. And you just hit enter 3 times, and it gives it to you, right? So R, and it says round this to the nearest 10 thousandths. So R is about negative 0.0817. So I just took the number that they gave me and rounded to the nearest 10 thousandths place. Okay, that's another point. Let's get our full 6 points. So the t-shirt and the hoodie are removed at the same time. Determine when the temperature will be the same. So now I have my 325, right? E to the negative 0.0735. I have my first equation, and I have to see, and this is plus 75, and then I have to see when that's equal to my second equation, which is 375 now, right? 400 minus, and then e to the negative 0.0817, that's the number that I just found for my r, t, and I have plus 75, okay? So now my plus 75s, right? I could just minus 75, minus 75, and they cancel out. These cancel. So I have to see where is 325 e to the negative 0.035 t equal to 375 e to the negative 0.0817 t. And this is, again, straight calculator. See where they intersect, and you get t is about 17. So it says determine when the temperature to the nearest minute. So this is about 17 minutes is the answer. And again, please do this yourself to make sure. That is a lot of points that we just accumulated right here. The other questions that we skipped, let me just go back and see if there's anything that is fairly easy that we can do. We did a lot. So number 6, I did say come back to this. Number 6 is a fairly easy question. However, you need to know that in the reference table, there is a formula that we need to use for number 6. Um, so if I take a look, at the question, it says the sum of the first 20 terms of the series. So we're looking for a series function. So there's a geometric and there is, and yeah, there's only one series function. So this one right here. So a1 minus a1 r to the n over 1 plus 1 minus r. So I'm going to use that. So I just wrote down that formula here. So now my a1 represents my first term. So I'm going to put the number -2 there. Minus my a1 again is -2. You see how I'm doing this? Right, just substituting some numbers in. My r is my common ratio. That's the number that I multiply. So what number am I multiplying to get to the next number? So my r here is, if you're not really sure, take the second term, which is 6, divided by the first term, which is -2. 6 divided by -2 is -3. So I'm going to put in a -3 here, and it's asking me for the 20th term, so n is equal to 20 here. I'm going to put a 20 all over 1 minus r, which is -3. Put this whole thing into the calculator, hit enter, and you're going to get answer choice number 3 is your answer. Okay. I don't feel the need to go through too much more. Number 13. I say that, but then I'm going to go through it anyway. You do need to know this formula for number 13. Period is equal to 2 pi over b. And this is like a trig question. but it's all good. We could do this. So it's telling you the graph can be modeled by this, da da da. And so it says, all right, so for this question, the B, here's your A, the amplitude. We kind of did this last time. So A is 5, and it's always the absolute value. The B is a number that's in front of the variable. So B here in this case is K. And now let's talk about what this P means. Period is how long it takes for the graph to make a full cycle. So if I start here, then it's going to have to end here. If I start here, it's going to have to end here. Okay. So if I look at my graph, let me do this in a different color so you might be able to see it. The graph starts here. Where does it get back to that spot? It goes up, it goes down, it comes back up, and it's at 1. So my period, my P is equal to 1. So now I'm taking my things that I have. So P, right, which is 1. So 1 equals 2 pi over B. I don't know what my B is. It's called K. So I'm going to solve for my K. So I'm going to cross multiply here, right? So K times 1 is K is equal to 2 pi times 1 is 2 pi. So what is my K? My K is just 2 pi. Done, right? That's how you do question number 13. I'm trying to see if there's any other ones that are pretty straightforward. Da, da, da. Margin of error. Mm, This is pretty straightforward. So the margin of error, I'm just going to go through this with you, is just going to be 2 times your standard deviation. And they tell us that the standard deviation is right here. So 2 times 0.035, hit enter into the calculator. This is just a random fact. For this next one, they give you cosine, they give you tangent. Well, they tell you tangent is less than 0. What is the value of sine? This is a calculator question. You might have remembered some of this from geometry, I hope. Um, this is a calculator question. So they're telling you cosine of a something of an angle is radical 5 over 3. I should have not skipped this because you could have done this in geometry. Anyway, so to find out what A is, you hit second cos because we want to look for the angle, and you literally just put in the function. So alpha y equals option number 1. So we're going to put radical 5, rad 5. That's not rad 5. I said rad 5. Delete, delete. Okay. So second, right? And then 5 on top and a 3 on the bottom. Hit enter and you get this. So that's your angle, right? And now we want to find the sine of that angle. So you hit sine, so S-I-N, and go up and grab that and hit enter. And then see which answer matches the mark of the devil. And so this one right here, if I plug this in, hit math, fraction, hit enter, I get 2/3. So now is it negative or is it positive? So for this one right here, in this sign, right, your x and y's are both positive. In this one right here, it's negative comma positive. In this one right here, it's negative comma negative, right? Like -3, -5. And in this sign, in this quadrant, the signs are positive comma negative. So this is the one new thing that you're going to learn. The first number is your cos, the second number is your sine. So it's telling you, right, where are we looking? We are looking at, so this is cos, this is sine, so on and so forth. So we're looking where cosine is positive, see that? Because that's a positive number. So cosine is positive in these two quadrants. It's saying, and tangent, where tangent is negative. Tangent, this is another thing that you do need to know at some point, is y over tan is sine over cos. So they're telling you that tangent is negative. So positive divided by positive, tangent would be positive in this quadrant. Negative divided by positive, tangent is negative in this quadrant, which means that we are in quadrant 4. And the value of sine, because the first number, again, remember what I said? The first number is cos, the second number is sine. So cosine is positive and sine is negative in this quadrant. So my answer would be -2/3, not just 2/3. Okay. If you didn't get that, no big deal. You got a lot. based off of what we've done so far. So you should feel good. We are kind of like an hour in. I think we did everything except for like maybe this one or two problems. I'm not worried about the one or two. All right. Good job.